All right. Good morning, good evening, good afternoon, whatever it is, whatever time it is that you're viewing this video. I hope you are having a wonderful day. Now, my name is John Sinnott, and I unfortunately don't have any pre existing footage of me teaching. Now, I did student teach at a public school district this year from January all the way up until May, and it was in person and while I have done online tutoring, but actually like recorded any lessons per se. So figured I'd just take today to talk about one of my favorite topics in algebra, just because it's so applicable. And in this case, I'll talk about some geometrical components to completing the square, which is actually what I wanted to show today. So um, let's consider this example here. Now, my objective is to complete the square. This is kind of an issue though, because I believe this is first introduced in Algebra 1. And it a lot of times is a reoccurring factoring technique that shows up pretty much all the way until like even something as complex rather is like differential equations, where you might need to get something in what's the word I want to use, standard form per se, when you're going from like the X domain to the S domain when doing something crazy like a Laplace transform. But of course, this is just an algebra topic, so I'm going to leave it at that. Now, I can definitely do one thing here, and regardless of the factoring technique, I would definitely recommend this as a first step anyway. And it's that we can actually divide this off by a 5. All right, or GCF 5 divides our equation here. So I actually just want to rewrite this when divided by 5. So I have a, I'll divide off the 5 actually. So I just have x squared minus 14x plus y squared minus 4y plus, oh geez, what's this going to be? 52, I believe. Let me just double check real quick. We don't want to make any early math mistakes here. And it is 52. Cool. And that's set equal to 0. Now, we want to complete the square, and I'll explain like what the rationale is and where this name comes from. But here's my recommendation here. Now, our terms, in terms of x's and y's, they're in order already. But let's say they weren't. I would want to get my x terms, regardless of the like degree. I definitely want to group my x's and my y's together. And then any constants, I'm actually just going to move over to the right side. And I'm actually going to color coordinate here. So we have x squared minus 14x plus y squared minus 4y. That's just going to equal negative 52. Now, a student who hasn't learned completing the square, or maybe they've forgotten, they might do this. And can I really blame them for it? No. But this isn't exactly going to do too much for us. And it doesn't really mean much in the context of, well, completing the square, right? But what if we did this? X squared minus 14x. I just leave it like this. I'm just copying down. Now, in algebra, we can manipulate to our liking, just as long as there's I guess the word would be equality here. Like, I can't just introduce, say, a plus 300 without also introducing a plus 300 over here. Now, when I moved my 52 over, I subtract 52 here to cancel. But I can also subtract 50 here. Hence, why negative 52 resides on this side. And the same thing works with that first step when I just divided by a 5. I also divided by 5 here. It just so happens that 0 over 5 is just 0. Now, with that in mind, I might ask my students, hey, could we maybe think about this in small groups for a couple of minutes? Now, depending on their feedback, I'd always like to hear student responses, and that might even allow us to go into another student-led discussion. But again, that's all variant on these student responses here. But the conclusion that I would eventually get to is that, hey, algebra allows us to manipulate to our liking. Now, I know x squared minus 14x. What if we actually did try to get some type of square here? In fact, we want a perfect square. So we can take, like, for example, we can call this an a term and a b term. We could just half 14x and then square it. So b over 2 is kind of a rule that we can use for figuring out our c term. So it's just going to be plus 49. Now similarly, we can do plus y squared minus 4y plus 4. And if you're wondering where that comes from, I can just do negative 14 divided by 2 and then square it. So I should actually probably write this up here. And that's going to give me my c term. Now, I would use this as another opportunity for student-led discussion, because my next question would be, am I done here? Like, is there anything wrong with this? I am asking it for a reason, but it's up to the students to figure out what's wrong with leaving it like this. Now, I've just introduced a plus 49 and a plus 4. But I can't exactly do that without also adding it on the right side. So that's what I would be looking for from my students. And it turns out this becomes a 53, so we can actually just reduce here. Now, at the same time that I'm going to reduce the right side, I actually have a perfect square trinomial in blue and in green. So you want to ask yourself, okay, what two numbers add to negative 14 and multiply to 49? Well, you would say, oh, it's just negative 7 and negative 7. So if you'd like, you can do x minus 7, x minus 7, or we can write x minus 7 squared plus y minus 2 squared. And that's just going to equal positive 1. Now, let's say we wanted a geometry component here. Now, if this was just your ordinary completing the square, we can just root each side and call it a day. But this is actually the standard form of a circle. In this example specifically, we have a center at 7, 2, and a radius of positive 1. And if you're unsure, we can actually just plug this into Desmos. So I'm going to go ahead and do that. we go on Desmos, and we have x minus 7, square it, plus, I believe it was y minus 2 squared, yeah. That's just going to equal 1. And it looks like we have a circle centered at 7, comma 2 with a radius of 1. And that's pretty much it for this mini lesson. I didn't want to, I guess, yap for like 20 minutes. It would take quite some time to upload on YouTube. But of course, there'd be a lot more questioning and some other applicable technologies that I could have used here. But I didn't want to just submit this application without at least showing what my teaching style looks like. I like to use a Socratic style to instruction because I think it motivates student discussions, and of course I like direct instruction as well. As I actually felt this lesson that I just done felt like direct instruction, but I didn't really have a live sample of students to work with here. Now, yeah, in any case, I guess if there's any questions, just feel free to reach me at 631-885-0407, or at my email, which is just jackpsinnott@gmail.com. And I'm hoping to hear back soon. So take care and have a good night.